Good afternoon, everyone. Am I audible? Perfect. So there's just one session before lunch, so I'll kind of try to quickly wrap things up. But I won't even go so fast that I'm not able to convey what I've prepared. So today's talk is more centered around how you create machine learning models using existing things that are kind of really cool that you can utilize to create good machine learning models. Once the model is created, how you can utilize it and create web applications out of it. So the talk today is building ML-powered applications using TensorFlow Hub and Gradio. That is the session today. I also happen to run YouTube channel, so I think my introduction is already done, so I won't go over it again. So I'll start off today's discussion with a quote. Don't reinvent the wheel, just realign it. So a lot of times what happens is when you have use cases wherein you have to create machine learning models, it's often advised that you should use something that is readily available and not something that you have to build from scratch. In 2023, a lot of things have been created so far. There are pre-trained models that are already kind of making a lot of places in a lot of, say, different machine learning applications, which is where today's discussion is how can you use something that already exists, which is something that is secure, which is something that is, say, much more secured in terms of the usage, something that is latest, something that you can directly utilize and create solutions around it. So, how many of you have heard ChatGPT? I don't expect even a single hand down. I expect everyone to raise their hands. So ChatGPT has taken the entire industry by storm. Even if you're not associated with ML, I think one of the things that everyone's trying to understand is how do you write good prompts, what are good prompts so that you can get the right output. So what is happening right now is, or where I'm taking you right now is, the amount of research that's happening in ML currently is moving at such a fast pace that it's very difficult to keep track of everything, right? Which is where what happens is you have closed door models. So is ChatGPT open source, closed source? Do you have access to the model weights? No, right? So behind the scene is where ChatGPT is. So OpenAI has their APIs inbuilt, wherein you can access the APIs, but nothing is open source. In order to counter OpenAI, you have different models that have come up, which are again open source in nature. Your huge large language models that have been open source right now, all of them given for a data scientist who wants to be, say, in tune with what is happening in the current industry with respect to data science and machine learning, there are various challenges that he goes through. So for example, if I'm building a machine learning powered application, one thing that I'll do is I'll kind of go through research papers. So research papers are that one source of truth that you start learning your, or you start working on when you have a use case in hand. Now, one of the challenges that you face when you have, say, research papers as well, is you would have different GitHub repositories for different ML-powered applications, right? Now, the question arises, how do you use it? So not a lot of repositories will have good, clear README files. Not a lot of repositories would also convey what is the data set that they've used in order to train the model. Is it safe given you're downloading something that has been uploaded on a repository? If you download it, chances are that your machine can also stop working as well. So what is the best thing that you should do? The other question that a lot of people have is this the latest version of the tool? Can anyone tell me when was the first version of ChatGPT out? It was last year, but month? November, October end November, I guess, right? When ChatGPT was launched, initially the model was 3.5, right? You now have access to GPT-4 as well. In 6 months of time, you have access to the most latest version of the model as well. So now, given if there is an open source repository that you want to use in your ML-powered application, the only question that you have is it the latest version that you're using? You don't want to use something that is outdated in nature, which is where there is one tool or there is one site that can kind of solve a lot of issues for you, which is TensorFlow Hub. So TensorFlow Hub is the GitHub for machine learning models. So essentially, when you think of creating a solution around image classification, when you think of creating a solution around, say, text classification, all of these solutions that you think of, there are already pre-trained models that you can directly utilize from TensorFlow Hub. What all sectors or what all sections are there in TensorFlow Hub? You have models related to image. So in images, you will have something related to image classification, image segmentation, and say what else? Style transfer based models. So if you have an image which has a certain painting style, if you want to transfer it into your photograph, you will have models for that as well. For text, again, all the models that you see right now, the chatbots that are gaining a lot of popularity, all of them are text models. So you will have NLP based models like text classification. You will have different tagging based solutions as well. Videos are nothing else but a stream of images flowing at some frame rate. So if you can classify images using a good model, you have video classification models as well, wherein imagine you keep a model that takes in CCTV input feed and then predicts if there is someone unknown that enters your house. So there are pre-trained models for that as well that exist on TensorFlow Hub. And then you have audio classification models. So imagine a case wherein you have a customer service industry which wants to classify what the customer representative is speaking about and what the end user is asking about. If you want to do an analysis on that, which is where your audio classification models would come in handy. Okay? So these are some range of models that already exist on TensorFlow Hub. Now the question is, how do you utilize it? Again, before we go to the utilization section, now I'll talk about why TensorFlow Hub is so awesome. Firstly, if you want to create CI/CD pipelines out of TensorFlow Hub, then all of the TensorFlow Hub models can be extended to the TensorFlow Extended suite. So TensorFlow Extended is basically a suite of tools wherein you can create pipelines. So the previous section was about creating pipelines, right? So here, if you have your ML model, if you want to retrain models after a duration of time, how do you do that is where your TensorFlow Extended suite comes into picture. If you are one of those wherein you want your model to reside in a web browser, if it's a small model that you want to make a prediction on, which is where you can deploy a model on TensorFlow JS, which is TensorFlow JavaScript. So you take the original model, you compress it down, and you then make a prediction from TensorFlow JS, which is TensorFlow JavaScript. How many of you have heard of Arduino boards, Raspberry Pi? So if you want to use machine learning models on devices with low CPU, low memory, low storage, then you have an option of TensorFlow Lite. So TensorFlow Lite helps you deploy models on edge devices and make inferences on them. Finally, Coral is again a type of an edge device, which is again, you can convert your TensorFlow model into a TensorFlow Lite model or a Coral equivalent model and use it. So if you look at the ecosystem, then the entire ecosystem is stitched up, right? You can create a model that can be deployed on a server. You can create a model that can run on a website. And you can also create model that can also run on edge devices like Arduino boards or your, say, cell phones as well, right? So this is the power of the entire TensorFlow Hub ecosystem, wherein you choose a model, take that model, retrain it for your purpose, which is what we'll kind of discuss today, and then deploy it to any of the environments that you really like, okay? Now, how do you use? So the most important question at this stage is, how do you go about using the model? Which is where, again, a question so that everyone's awake before lunch. This is a dog. I'm assuming everyone thinks that this is a dog. What is the breed of this dog? Can anyone give me an answer? Like a random guess is also fine. Poodle. Half of it is correct. There's one more part before that. So I won't disclose, given that this was not very clear, I won't disclose the name. I've already received the right name, but this particular breed of dog, if I want to make a prediction using a pre-trained model, I'll use TensorFlow Hub for this particular activity. I start off with some simple lines of code. I import TensorFlow as TF, TensorFlow underscore hub as hub. So if I want to make a prediction of, say, 30 images at a time, I'll pass in a set of images in a batch, which is what I've created as, so this is not the actual code. This is what I'm showing you is the pseudocode of the entire process. Then what I essentially do is I call hub.keras layer and I pass in the exact URL of the model that I want to utilize. I save that entire model into a variable called as classify. I pass in the list of images that I want to classify into this particular variable that I've created. And finally, I get a list of probabilities. I'll get around 1000 probabilities. The reason is my model has been trained for 1000 classes. So I'll get 1000 probabilities. For one input, I'll get 1000 probabilities. The ID at which there is a maximum probability score is the class that has been detected in that particular image. Okay. Now how do you detect the class with the maximum value is where tf.argmax comes into picture. Okay. And finally, I print the class ID. Okay. Now, rather than passing in multiple images, I'll just pass one image. So when I pass this image, the class ID that emerges out as the maximum is toy poodle. So yeah, I mean, it was already guessed correctly, but that's the whole idea, right? So I've used something that was already existing and I've created a solution around it. Now, there are cases wherein out of 1000 classes, you want to create a custom solution wherein you have a different use case altogether. Not every time will you find a pre-trained model for your exact use case, which is where there is something called as transfer learning, right? So everyone awake, when you give reviews on Amazon, what are the kind of reviews that you give? Either you're very happy or you're very sad, right? So you have positive reviews and negative reviews. Now imagine you find a model on TensorFlow Hub that gives you two classes as outputs, positive and negative. If your use case is kind of covered in the entire aspect, then you use that model directly. But if there are use cases wherein you will have reviews which are neutral as well, right? So for some products, you will say it's an okay product, so not that great, not that bad as well, right? So when you have reviews which are falling in between, or when you have sarcasm as well in reviews, in such cases, you will require a custom model that you directly cannot, say, create from either scratch, or you cannot directly use it from TensorFlow Hub as well, which is where you have something called as transfer learning that comes into picture. So if you look at the first left-hand side section, what you have here is basically a neural network that was trained for two classes, okay, which is positive and negative reviews. Now what I do is I chop off this particular section, that is the input section. I chop off the input section just before the output, the final output layers, and I take this forward and I add new weights to it. That is the 4 output classes that I want to classify. I retrain the model based on the input data that I have. So the initial layers are frozen as it is, and the final layers are what are retrained again. Okay. So again, going back to the use case, we have 2 classes, positive, negative reviews. I want to introduce 2 more classes, sarcastic reviews as well as neutral reviews, which is where what I've done is I'll pass in new data again. I'll keep the base model as it is, and I'll retrain the final layers of my neural network. Okay. So this is the approach that I've already captured in a slide. So I obtain a pre-trained model, I create a base model, I freeze the layers. So previously, if you see clearly, I've already frozen some layers here. So I freeze some layers. I train the entire model with the new data set that is there. Again, the data set that I provide should be labeled in nature. So all of this is supervised learning. So I retrain the entire model again, and I keep improving the model via fine tuning so that I have the best possible model in hand. Okay. Now I'll give you an example of the entire case that I've just spoken about. So I have a total of 5 classes of flowers. So you have sunflower, you have daisy, you have dandelion, you have tulips, and the other classes that are there. Now, the model that I showed you was not capable enough of classifying these 5 categories of flowers. It was capable enough of doing it for different classes like dogs or the other animals that are there, but it couldn't classify, say, flowers to this minute level. It can classify whether it's a flower or not, but it cannot classify and tell me the class of the flower. which is where what I'll do is I'll take a pre-trained model and I'll retrain it. I'll show you the entire process. So in this example, the data set is almost, the classes are almost evenly balanced, wherein you have almost equal number of samples for each class. So what I do in this case is, if I go back again, I take this section of the model, that is the feature section of the model, chop off that section, add new weights to it, and retrain the entire piece again. So what I'm doing is, I'm taking this section, I add 4 output weights, I connect them to the final layer of my existing model, and I retrain only the final layer of my network. So how do I go about doing that? Again, the imports remain the same. What I do right now is the second line of code that you see, which is data_root, helps you download the entire data file into the local working repository. So data_root contains the flower. So again, this data set that I'm using is an open source data set. It's readily available on the TensorFlow website, which is what I'm using to download it in my local machine or in Google Colab or any other cloud environment that you use. I define batch size, image height, and image width, and then I kind of create a Keras pre-processing pipeline wherein I pass in the training data set, the validation data set, I specify the split, I specify the seed value so that I'm able to reproduce all the output again and again. If you plan to try the entire activity again, then you should be able to reproduce the same results as what you're seeing with my notebook as well, which is where the seed value comes in very handy. And then you specify the image size. If you look at the values here, image height and image width, 224 cross 224, is there a reason why I've chosen that? Like, is that my lucky number? Can anyone make a guess? Why is it 224 cross 224? Anyone can make a random guess. There's no rocket science in that. It's definitely not my lucky number, so I'm not using it just for the sake of using it. Anyone? So whenever you go through the TF Hub documentation site for that particular model, you would have input dimensions written in terms of what input is expected by the model. So there is no rocket science in terms of why I've used 224 cross 224. Whatever model you use, essentially it all boils down to what configuration of inputs does it expect. So this particular model that I'm using expects my model images, input images, to be resized to 224 cross 224. Okay? Once I've defined the pre-processing layer, now what I'll do is I'll only extract the feature extractor piece of the model. Going back to this particular section again, this entire model that you see with the output is something that I don't require right now. I only want the initial layer of the model, which is where the section that I've highlighted is what I will download and not the entire model. In the previous code, this particular code that you see here, I have downloaded the entire model with 1000 prediction outputs. I don't want that. I only want all the layers except the final output layer to appear, which is where I only want the yellow selected region to appear, which is what I've done in that section of code, which is what I'll show you right now. So this piece, the first line of code, is where I'm downloading only the yellow section of the model, which I'll keep as it is. I'll add final layers to the model based on how many outputs I want. How many classes are there? How many, say, flower categories are in this particular example? Is everyone awake? Yes? Cool. So there are total 5 classes in the entire images dataset that I've used. So I'll kind of add 5 output nodes as compared to 1000. I'll have connections between my output final layer and the final output layer, which is where I define a variable called as number of classes. and I say length of number of classes equal to length of class names. Finally, I also create a model using the sequential class, wherein if you look closely, I've added the feature extractor layer, which is the yellow box, and the final dense layer, which contains 5 classes or 5 nodes which are there. The connections will automatically be taken care by Keras. And this is the model summary output. So once you create deep learning models, you will have this kind of a summary as well, wherein you have total number of parameters. So if you look at the total number of parameters here, you have around 2.2 million parameters. And in the final output layer, you have around 6,485 parameters. Now, if you go down, you have 2 sections, trainable parameters and non-trainable parameters. So if you remember our initial discussion as well, I don't want to train the initial layers. I only want to modify the final layers, which is what you would see here as well. So total parameters are 2.2 million. Trainable parameters are 6,400. And non-trainable parameters are 2.2 million again. So what are we trying to do? We'll pass in images, we'll retrain the model, but we'll retrain the output layer only. So I only modify the weight section of my final layer and not the pre-final layers that are there. Okay? Then I kind of compile the model, I pass optimizers to it, I specify the loss function, and I specify what matrix am I chasing for. Do I want a higher precision model, or do I want a model with a higher accuracy? Then I start the training process by calling the model.fit function. And this is the graph that appears. With every iteration, my loss keeps going down, and with every iteration, my accuracy keeps shooting up. I stop at around 10 epochs, and this is what I observe. I have around 87% accuracy for 10 iterations or 10 epochs, which is something that I'm kind of happy or satisfied with. What I do next is, I'm kind of satisfied at this point of time with the model. This is the overall confusion matrix as well. So the confusion matrix clearly shows you that you're getting some misclassifications. You're getting some misclassifications for roses and tulips, which is the last row and third column, if you see that carefully. But the overall diagonal elements, which represent our main classification, or the main true positives or true negatives, all of those are correctly classified here in this case. So what we have done so far is, just a recap, we've gone through a process of downloading a model from TensorFlow Hub and using it for our use case. What I've done next is, I've kind of taken a pre-trained model, I've modified it to my current use case, which is creating a model that can help me classify various flowers. Now, in around 6-7 lines of Python code, I'll show you how you can create really good, web interface that you can directly utilize and create web applications out of it. Okay? So the library that I'm using is Gradio. So Gradio has caught up a lot of popularity. Very recently, it was acquired by Hugging Face as well. So Gradio helps you create really cool web interfaces, not fancy, but something that is structurally good for usage. It helps you create web interfaces that you can utilize for machine learning tasks, such as this. What I do is I import Gradio as GR. I have a function called as define predict underscore image, wherein I pass the image. I reshape it based on what the model expects. I call the model.predict function. And finally, I return the classes along with their probability scores based on the prediction that the model is making. I define 2 labels, input and output. So you have the image label, which is the input label. You have the label, which is the output label. And finally, you create an interface. Creating a web interface is basically a single line of code, which is the final line of code that you see. gr.interface, call the function that is used for making that particular prediction, or which is the function that you want to use in the entire input to output conversion is what you specify. You specify the input, that is the image in our case. You specify the output, which is again a text-based output, which will specify what is the probability of a class that has been detected. and you can ignore the interpretation and default equal to true right now. But the overall crux is you have one line of code to create an interface. Defining input and output is just two lines of code, okay? Now I go to the next section. Can anyone tell me this? What is this flower out of the 5 classes that we have discussed so far? Rose? Isn't this tulip? Isn't this dandelion? Yes? So we have some votes for dandelion as well. Some votes for tulip. Is this sunflower by any chance? No, right? Okay. So everyone's awake before lunch. So what we've done previously is we've created this particular interface using those 5-6 lines of Python code. So just to recollect, this is the code that helps you reach here. This is the code that helps you reach here. I take the image, so it clearly mentioned drag image here or click to upload. So you take the image, upload it to this particular web UI, click on submit, and finally you have the output as well. So this is basically a rose. So you have 100% prediction stating that this is a rose. So what we've seen so far is I had a simple use case wherein I wanted to create a machine learning model that could help me create a web application to classify flowers. You can have a different use case, right? Given that we are in Bombay Stock Exchange today, a lot of places you require KYC documentation to happen very quickly. There are companies in fintech that require you to classify financial documents such as your PAN card, Aadhaar card quickly. So what you can do is, you can take a pre-trained model, you will have some set of data which would be labeled in nature, you will have labeled data set as well, and then you can use an existing pre-trained model, not specifically this one, maybe a different model which will already be classifying different documents, which is something that you can definitely look up on the TensorFlow Hub website. You basically download, you basically have images labeled. Once you have images labeled, you can then retrain it the way I just did, create a simple web UI, and if it's a fintech startup that's kind of hunting for money, then you can show this demo to investors as well. There are multiple use cases that are possible. Like for example, how many of you have used Google Lens to make a prediction of a landmark? So there are pre-trained models available on TensorFlow Hub, wherein you can download a model, create a web interface like this, or you can create an Android application as well, wherein so a lot of times when you travel international, you wouldn't have internet as well, right? So which is where Google Assistant won't work, which is where you can create your own landmark detection model, wherein you can just point your camera phone to that particular landmark, and you would have a prediction as well. All of this entire piece is pretty much possible using TensorFlow Hub. So this is what I wanted to show you today. Given now, although I'm not covering that section, but given if you have a web application running, like a Python web application running, which is created in Gradio, you can easily take that, say, Python file along with the requirement file, push it to GitHub, push that piece to GCP and create a service around it. So if you don't want to use, say, the Hugging Faces direct spaces, and if you want to add a layer of, say, security, which is where GCP would come into picture, you can take this particular Python file, the model, the requirement file. You can have the model hosted into Google Cloud Storage bucket. You can host this on Google Cloud Run based on the various parameters such as pricing and what is the overall usage of that app as well. And then you can basically deploy this particular web app that you've created using very few lines of code into a GCP environment, and then basically utilize it. And you can also monetize it if there is something that is kind of adding value to the end users. You can monetize the API as well. So there are various ways of how you can use this. What I discussed today is one of the way. So yeah, this is all that I had in today's discussion. I also happen to create videos on machine learning data science. So the QR code that you see will take you to my YouTube channel. So if you like today's talk and if you are interested in learning more about data science, machine learning, feel free to go through my channel. And that's all that I had for today's discussion. I hope you had a good time and hope you learned a lot today. Thank you.